Intro to Stats. This is section 4.2, Sampling the Good and the Bad. Suppose we want to know how much time students at a large high school spent doing homework last week. We might go to the school library and ask the first 30 students we see about their homework time. The sample we get is called a convenience sample. A convenience sample consists of individuals from the population who are easy to reach. So it doesn't take much effort to find these people. I can see them or they're easily accessible. This is a convenience sample. What might be a problem with asking the first 30 students entering the library about how much time they spent doing their homework? What could be wrong with doing that? Well, students who hang out in the library probably spend more time doing homework than a typical student. What would happen to our average amount of time spent on homework then? Would it be too high or too low? Well, our estimate for the average amount of time spent doing homework would be way too high. So if I'm asking kids who are already in the library, because a lot of people go to the library to study, so if they're in there studying, then they're spending more time doing their homework. That's different than if I went to the cafeteria and asked people how much time they spent. I wouldn't know for sure if they are doing a lot of homework or not. But typically, people who are in the library probably are doing their homework. So that would make this thing way too high. What do you think would happen if we repeated this sample over and over again? So let's say I did this on a Tuesday morning, and then I did it on a Wednesday morning, and then I did it on a Thursday morning. What's going to happen to my sample over and over and over again? Well, we're still asking people who are going to the library, so we would almost always overestimate the average time spent doing homework in the population of students. Okay, now we're going to see this word a lot here too. Overestimate. They're giving me a higher number than what maybe the rest of the student population would be giving me. So now we're going to talk about bias, and this gets confused with the statistical meaning of bias and what we think of bias in the real world. So the official definition is the design of a statistical study shows bias if it is very likely to underestimate or very likely to overestimate the value you want to know. So this isn't the same as somebody being biased, like maybe somebody only talks to people who are in the same grade as them. That's a biased person. That's not what we're talking about here. We're talking about bias in a statistical study. So it's going to be very likely to underestimate or very likely to overestimate. That's where the bias is occurring. So it's not just bad luck in one sample. It's the result of a bad study design that will consistently miss the truth about the population in the same direction. So that's like me asking kids that are going into the library. That's the same group of kids probably. Every morning, it's going to be the same situation. Even if it's not the same group of kids, it's the same type of kid. It's probably one that's doing their homework. So this is going to be biased because a lot of them spend a lot of time doing their homework. And again, maybe that wouldn't be the same response I got if I went and stood in the cafeteria and asked that question. Okay, here's our problem. A farmer brings a juice company many crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. Explain why this sampling method is biased. And then when you're done with that, is the proportion of damaged oranges in the sample likely greater than or less than the proportion of all oranges in the crate that are damaged? Okay, so think about a box of oranges, because a crate kind of looks like a box, and they stack all of these oranges on top of each other. And the inspector is only looking at the top ones. Well, what do you think's happening with the bottom oranges? What's going on in that box? So if I stuck my hand down at the very bottom, what's going on with those oranges? Are they going to be as nice and round and juicy as the top ones? I don't know. Probably not, because they've got all of the weight of the other oranges sitting on top of them. So if an inspector is only checking the top ones, they're not getting a real sense of what might be going on in that entire crate. So it is likely that the oranges on top of the crate are in better condition than the oranges in the rest of the crate. Perhaps the farmer put the best oranges on top. Like if I knew that's what all the inspector was looking for, then I'm going to put my best ones on top, so they'll buy them. Or the oranges on bottom may be damaged due to the weight of the oranges on top of them. This means that the sample proportion of damaged oranges is likely to be less than the proportion of all oranges that are damaged. So this is bias right here. Well, if you said that it is likely that the students in the gym after school are more active and physically fit than the rest of the students in the school, then you just showed that this is biased. If kids are in the gym after school, they're probably on an athletic team of some kind or intramural sport of some kind. So that means that their sample mean weight is probably going to be smaller than the rest of the students in the school. They're probably physically fit. So they probably are going to be within a normal weight range or slightly around that versus anybody walking up and down the hallways. People might think biased means that someone has a strong opinion, but biased has a special statistical meaning. It means that a sampling method tends to miss the target or the population value it was trying to estimate in one direction, either too high or too low. So again, the word biased in society versus in a math classroom means different things. So we don't want to miss the target on this one. Another type of sample is called a voluntary response sample, and it's just exactly what it sounds like here. This consists of people who choose to be in the sample by responding to a general invitation. So somebody wants to do it. Somebody volunteers their time to be in the survey or ask questions or whatever. Many websites have polls that ask visitors to express their opinions. So I'm sure as you guys have been online shopping, a little ad will pop up and it'll say, fill out the questionnaire, and that's up to you whether you do it or not. You can always click out of that. So these polls, along with other call-in or write-in polls, are not reliable because they use the voluntary self-response. Now, sometimes this is also called the self-selected sample, so be careful to use both of these. They'll show up both. So voluntary response means I voluntarily choose to participate in this. Nobody is forcing me to. Also called self-selected. Okay, here's our problem. The athletic department at El Dorado Community College wants to learn more about the physical fitness of students at the school, including the number of push-ups that students can perform. To obtain their sample, the athletic department sets up a booth in the center of campus with a sign that says, "Free physical fitness training." Explain why the sampling method is biased. Is the mean number of push-ups for the members of their sample likely to be greater than or less than the mean number of push-ups for the entire student body? Okay, so we're on a college campus. There's this sign that says free physical fitness testing, and I'm supposed to do push-ups in front of everybody on campus. So what are we thinking here? Biased? Well, it is likely that only physically fit students are going to volunteer for this. So people who are overweight or can't do push-ups aren't going to volunteer for this. They're not going to do that. Students who aren't in good shape or are unlikely to voluntarily take this physical fitness test in the center of campus too. So it's also where everybody can see you. As a result, the mean numbers of push-ups for the members of the sample is likely to be greater than the mean number of push-ups for the entire student body. If more people are volunteering that can do push-ups, that number is going to push the mean high versus the people that are not going to do it. Okay, So mix it up, talk to a couple different people now. So move around, check somebody, new group out. I want you to discuss this one and then be able to defend. So it says the school nurse from the previous example decides to obtain a sample of 20 students in a different way. He submits a morning announcement stating, health data needed. If you are willing to be weighed, please come down to the health room this week. Explain why this sampling method is biased. Is the mean weight of the 20 students in this sample likely to be greater than or less than the mean weight for the entire student body? Okay, pause the video for about 30-45 seconds, talk it up with your friends, and then decide what your answer is going to be. Well, it is likely that only students with low body weights are going to volunteer for this test. Students who are overweight are unlikely to volunteer to be weighed. As a result, the mean weight for the members of the sample is likely to be less than the mean weight for the entire student body. Okay, our next type of sampling is called a random sample. And this consists of individuals from the population who are selected for the sample using a chance process. So there is no pattern, no way to guess who they would be picking. This is completely random. And it's just by chance that they're being selected for this. In convenience sampling, the researcher chooses easy-to-reach members of the population. In voluntary response sampling, people decide whether to join the sample. Both sampling methods suffer from bias due to personal choice. The best way to avoid this problem is to let chance choose the sample. That's the idea of random sample. And this is also sometimes called random selection. So you might show that, that might show up on a worksheet, quiz, or test. So random sampling. It's done randomly. There's no pattern, rhyme, or reason. It's done random. It keeps it unbiased better. Okay, here's our problem. Explain how the athletic department at El Dorado Community College can avoid bias identified in the previous example. So this is where we had to do push-ups in front of the campus here. So how could I get that to be unbiased? Well, instead of recruiting volunteers in the center of campus, the athletic department could obtain a list of all students and randomly select 100 for physical fitness testing. Because no personal choice is involved, the sample should be more representative of the entire student body. So people aren't volunteering for this, and they're not conveniently picked because they were walking down the sidewalk. They were randomly selected and encouraged to do this. Okay, your turn again. Find a couple of people sitting next to you, discuss this, be able to defend your answer. Explain how the school nurse can avoid the bias identified in the previous example. Instead of recruiting volunteers to be weighed, the nurse could obtain a list of all students and randomly select 20 to be weighed. That would give you an unbiased sample.